Ollama recently announced Python and JavaScript libraries, which will make LLMs more accessible to more people and expand what's possible to do with just a couple lines of code. So to explore that, today I'll be using the Ollama Python library as well as Streamlit to build an LLM-powered chat app. I'm going to start by briefly walking through what each of these libraries are before moving on to the app itself. Now, if you're more comfortable with JavaScript, don't worry because I'll be doing a similar video using the Ollama JavaScript library soon. In the meantime, let's go. But first, I think we should understand what's wrong with using the command line interface. Ollama gives us a really nice interface that does everything that we need it to with regards to interacting with our LLMs. So why use this library instead? Now, I would say Bash is really nice for simple interfaces, but by and large, it's not how most people are going to want to interact with LLMs. You could use Bash to write your tools, and certainly there are plenty of people that do shell scripting professionally, but it's pretty inconvenient for the average programmer. Some great UIs for Ollama's API exist, like the Open Web UI, which I covered in my last video. However, even these, as good as they are, still don't give programmatic access to the underlying API. And the Ollama API itself is great, especially for doing just web requests. However, I don't really want to have to manage, the state of any of my fetch requests or deal with manually adding types to the request responses after I get them back. And so that brings us to the Ollama Python library. It's a Python interface that basically just wraps the Ollama API under the hood as well as provides types for us. So I have its GitHub page pulled up, and if we look at the actual code, we'll see that it provides types, which essentially just tells us, what is the response that we're getting? Are they integers? Are they booleans? Are they strings? And then for the client itself, we can see it's only a few hundred lines of code, but if we look at one of the methods that we're familiar with, for example, the generate method, essentially just giving a prompt and generating a single response. Under the hood, all that it's doing is just making a request, right? We're seeing it's posting to the API/generate endpoint, and then it's passing all the same parameters that we are already familiar with. And we can see that's also true of chat, embeddings, which we haven't seen yet, but we can even pull models through this library as well, and it's still just using the API under the hood. But the benefit of this is it gives us access to the entire Python ecosystem, so we can really easily do I/O, web requests, and we also have access to all kinds of tools and libraries that we wouldn't otherwise if we were just using the command line. So in order to begin, let's start by setting up our environment. So the first thing we want to do is confirm that our Python version is over 3.8. For that, we can just do Python -- version, and we see Python 3.8.18. That's fine. So if you've worked in Python before, you'll know that Python dependency management can be a bit of a pain. So we're going to be using a tool called venv to help us manage our dependencies and just scope them to our single project. So we're going to do Python -m, which stands for module. We're going to use the venv command, which helps us manage virtual environments. And then the last parameter here is just the location of where it's going to be storing those files. So in this case, I'm storing it in a directory called .venv. So that's going to create our virtual environment, and then we're going to activate that environment by doing source, and then the path to our virtual environment, it's binary folder, and then there's an executable called activate, and that will activate our environment for us. And we can tell it's active because our environment is now displayed right there in our terminal. Finally, we're going to install Ollama, and we're just going to do Python -m again, and then pip, which is the Python package manager, and then install Ollama. Great, and now we're ready to go. Now that we have the Ollama Python library installed, let's walk through a couple of the major functions that we'll be using in our app today. Before we begin, I wanted to note that you should have Ollama running in your system before we start. And also, if you're new to Ollama, I would recommend that you watch my beginner Ollama video, which I'll link above. But if you're not, this should be review for you. So to begin, let's go into our terminal and open up a Python session, and then we import Ollama. Great. So the first thing I want to cover is listing the models. For that, we just do ollama.list, and it's going to give us literally just the API response, right? So this is some really ugly JSON. I wrote a little bit of code just to clean this up. Now this is an array comprehension. So what I'm doing is I'm saying, for each model, get me the name attribute of that model. For model in the iteratable ollama.list, and then from that response, I'm just getting the model's attribute of that. And so that should just give us a list of all the names of each model returned by ollama.list. Next up, I wanted to cover the show method, and the show method is how we view the model file for any model. So for that, we just do ollama.show and then the name of our model. So I'm going to use Mistral, but you can use any model that you have on your system. And it gives us back a lot of stuff. We see that the majority of it up here is the terms and conditions. And so I wrote a little comprehension just to filter that out. So here I'm saying, give me the key and the value for key and value in ollama.show Mistral. And then items is how you essentially turn a dictionary into key value pairs. And then I'm just omitting the license key specifically. So that gives us a much shorter response. And here we have the template. So we have the model file, as well as the template and some other details, some sort of like meta level details about the model itself. And finally, I wanted to show off the chat method. So the chat method is obviously the primary way that we're going to interface with any of our models. And so for that, we're saying ollama.chat. And then this is all the same parameters that we would pass in through the API. So we specify a model, in my case Mistral, and then because this is chat, it expects an array of messages where the shape of a message is a role, which is either user, system, or assistant, and then your content is whatever the prompt happens to be. And then I'm also passing in stream equals false, so we're essentially just generating one single response rather than doing it one word at a time. Okay, so I'm asking it, why is the sky blue? And let's see what it says. Okay, and so this is what the response looks like. Again, it's just exactly the same as what we're going to get back from the API. So what we actually want is in the message object, and then within that, the content. So we could even destructure that and do response, and then message, and then content. Okay, and that's all that we need to know for now in order to get started with our app. So now that we know how to use the Ollama Python library, it's time to put it to work. But before we dive into the app, I'd like to invite you to like and subscribe. Now to power our chat app, obviously know that we're going to be using Ollama, but I also mentioned a tool called Streamlit. I'm here on their website, and Streamlit is essentially a Python library for creating user interfaces. It does a lot of magic for us, and so as we proceed through this, just expect that some of this stuff isn't going to be explicitly written out. But Streamlit really does make it easy. So it runs a server for us, it manages the UI, it manages state updates, and it even provides us with a set of components that we can just drop in to build a really great looking app. And in fact, it even has components specifically for chatting. And so we're going to be using some of these right here in the app that we're about to build. So while I will be explaining some of the methods that we're using from Streamlit, I won't be doing a deep dive on this whole library, so I encourage you to come back and look at the documentation yourself. So the first thing we'll do is start by installing Streamlit. Again, that's just going to be Python m pip install and then Streamlit. Should take a minute to download, and then we should be ready to go. In the meantime, I've created a new file up here in my IDE that's just called chat_app.py, but of course you can name it whatever you want to. So now that we're in our file, we can start by importing Ollama, as well as import Streamlit as st. It's common to alias Streamlit just to something shorter. You don't really need to, but this just makes us type less code. Okay, so just to get a feel for how Streamlit works, I'm going to type in st title and then Ollama Python chatbot. Now Streamlit gives us a whole bunch of methods, which again you can read through the documentation for, but this will just set the title of the page and give us a UI. This will give us something that we can display. So now we can come down to our terminal and just run Streamlit run chat app, and this will start a server and give us a page that we can actually view. So here we are, we're on localhost port 8501, and this is the title that we just generated. So that's really cool, it's already working. So now that we have the basic app running, the next thing that we're going to want is to have a user prompt. So the way I'm imagining this is we're going to have our title at the top, and then we're basically going to try and replicate the ChatGPT interface. So we're going to have the ability to select the model that we want to talk with, since Ollama provides us with a lot of different models. And then we're going to have the chat history, where it's going to be, the user prompt and then the assistant response. And then at the very bottom, we're going to have the user input. So in order to do that, we're going to use a method on Streamlit, which is just called chat input. So here I'm assigning a variable prompt, and I'm doing that using the walrus operator. Essentially, this allows us to assign a variable at the same time that we use it in an expression. So we're kind of saying if the output of this prompt is not nullish or is not falsy, then continue with the block. So once we have our user input, then we're going to want to render that input back into the UI. So we're saying with Streamlit chat message, and we're saying that the person generating the chat message is the user. Now, Streamlit, because it knows that it's going to be used a lot for chat applications, it natively provides us like automatic default styles based on if it's a user role who's delivering the message or if it's an assistant role or an AI who's delivering the message. You can also pass in arbitrary strings, but we get sort of styling for free if we just say user or AI. And what we're going to render into this chat message block is just markdown with whatever the user's prompt is. So we can save this and go back to our app. And you'll notice that Streamlit even picks up when the file changes. And so we can just rerun this. And here's our prompt bar, right? It's already styled as an input. We can say nothing much. And there you go. Once we hit enter, then it's rendered back into our interface. And we even see the little user icon here because we said the chat message was from a user. Okay, so now that we're able to collect user input and render messages, the next thing that we're going to need is a message history. So in order to do that, I'm going to use Streamlit's session state. Essentially, this is just memory that Streamlit will know that it needs to manage kind of in between renders and in between state updates. And so the first thing we want to do is we want to say if messages is not already a key within the session state, then we're just going to add it. And we're going to say session state of the messages is just an empty array. And as we go along, we're going to push new messages into that array. So the next thing that we want to do is use this history of messages to render them back to our screen. So we're saying for message in messages. And then again, we're using this with chat message block. But the exceptional thing here is we're saying, instead of passing in user or AI directly, we're actually saying, let's read that message's role. And then finally, we're going to render the message content. So as you sort of inferred, the shape of each method. So as you can infer, the shape of each message is just going to be an object with both a role and content, which we're reading from here. And then finally, every time that we get a new input from the user, we just need to append that to our list of messages. So here I'm saying session state messages dot append, and then I'm actually constructing that message that I told you about earlier. So we're saying the role is user, and the content is whatever prompt is that we got from our input. So now that we have a message history, let's save our file and try it out. So we can rerun. Hello, how are you? And there we go, our history is working. Now you might be saying, this is great, we have an interface and all, but this isn't very interactive. I'm just chatting with myself. So now I think it's time to add the Ollama chat using the Ollama Python library. So essentially we want the Ollama model to respond to us whenever we provide it with a message. So we're going to be in this if prompt block. After we display the user prompt, we're going to come in and we're going to start a new UI block with the chat message from the assistant. Next, we're going to use the Ollama library using the chat method, just like we had tried out before. And we're going to get a response from that. Now, the response is going to be in the same format as the API that we saw. So we're going to need to destructure that and clean that up a little bit. But let's go through the arguments one more time. So our model is Mistral. Our messages are just the same as we're keeping in our session state. And finally, I'm saying stream false. What this means is we're going to wait for the entire response to be generated by the model before returning anything. And here's that destructuring I was talking about. So from the response body, we're taking the message attribute and then the content from that. Next, we're just going to render that to the screen with st.markdown again. And then finally, we're going to add that to our list of messages. So we're appending to our state messages. And this time, we're going to be using the role of assistant. And the content is just going to be whatever the message was. So let's save this and try it out. Rerun. Okay, and so here we see that we have this little robot icon because again, Streamlit is kind of aware that there are conversations between humans or users and AI or assistants. We asked it to tell us a joke, and boom, here we have the whole response. That looks pretty good, right? Something that I think would take this to the next level is if we were able to sort of use the power of Ollama and choose which of any of the myriad models that we have on our system that we want to interact with. So in order to do that, I'm going to basically just create a little dropdown that we can use to select the menu with. So here I'm just going to say init models. This is going to look pretty similar to the messages above. If model not in st.sessionState, st.sessionState model, and for now we're just going to leave this empty. Next, I'm going to create our list of models that we can use to display to the user. I'm going to borrow the code from our earlier example, and this is just a simple array comprehension. So I'm saying the models variable is equal to the model name for each model in the response of Ollama list, which again lists all the models. And then from there, we're just taking whatever lives in the models key from that. And so this is just going to be a list of all the strings of the model names. And finally, I'm going to say st.sessionState model is equal to st.selectBox. And so this is a UI element that is going to return the value to us. So we give the option, or we give the user a prompt, which is choose your model. And the options that we give them are everything in our models list. And the last thing that we need to do is copy the state. And wherever we're hard coding our model now, we're just going to replace it with this. Okay, so let's save and rerun. Great, so now we have this element right here. It lets us choose from all of our models. We can tell that, these are the models that I have in my system now. We can choose phi, and that should work just fine. The final piece that I'd like to add to this is to make the UI a little bit better, where instead of having to wait for the model to generate its entire response before displaying anything to the user, I'd like us to be able to stream each word at a time as it's generated by our LLM. So in order to do that, I'm going to introduce a new concept potentially to you called generators. So generators are a Python concept that I can demonstrate right now, where essentially it allows you to make a function into an iterable. That means every time you call the function, it yields something new to the output. So by way of example, if you're familiar with the range command, which just returns a range of numbers, x for x in range 5, this is going to print the numbers 0 through 4. Let's see if we can use generators to create our own range function. So I'm going to say def my range, and then n is going to be the number that we go up to. I'm going to initialize a variable x equals 0, and then while x is less than n, I'm going to yield that number x. So whatever we yield is essentially what's going to be returned for that pass. And eventually this function or this generator will stop yielding, and that's how the calling function knows that its response is done. And then to complete our logic, I just need to increment this by 1. And so now if I do x for x in my range, this should give us the exact same output. Voila. And so this is just a toy introduction to generator functions and the yield keyword. So back in our code base, I'm going to create our own function, which is going to be called def model response generator. And it's not going to take any arguments. And we're going to start just by using the Ollama chat interface again, right? So we're using the same model from our state. The only thing that's different is we're going to be passing stream equals true here. And so what that means is instead of getting one big message, we're going to be getting a series of smaller messages that all actually have the same shape. And so while this itself is a generator and we can use it as such, I just want to parse the output. So the output of each yield statement is just one single string instead of this bigger object that we then have to destructure. So I'm just going to say for chunk in stream, yield chunk message content. And so for each chunk, this should destructure just the human readable text, which is what we really care about. So from here, we're going to take our generator name, and we're going to come down here to where we're generating the assistant response. And I'm going to replace, just going to get rid of our original Ollama chat because that's being done by our generator method. And I'm going to replace this with Streamlit dot write stream because they anticipated the use case where we would want to stream a response back to the UI. I'm going to pass in our method, and then we no longer need to render the markdown because this write stream is actually already doing that for us. Furthermore, this message variable now is actually going to be the concatenated response from the streamed output. And so we can still just pass this message back into our list of messages. So if I save this, go back to our UI, I rerun it, I'm going to choose Mistral, and I'm going to say, tell me one fun fact about llamas. Okay, and so there's always going to be a base amount of time that it takes for our computer to load the LLM model into the GPU, but we can see that now our response is being streamed. That was one word at a time instead of waiting for the entire block to be generated. And with that, that just about wraps up our app. So in only a few lines of code, let's take a look at this. So in only about 40 lines of code, we were able to create a really good looking UI. We're able to stream model responses so our users don't have to wait. We have interactivity, we have message history, and we even have the ability to choose which model that the user is interacting with. I think that really shows the power of bringing Ollama into the Python ecosystem. And I think it's also worth noting that now that we're in Python, we have access to all kinds of other tools. So if you wanted to chat with documents, if you wanted to load files, if you wanted to make web requests, if you wanted to save things to a database, Python gives you the ability to do almost anything. And in future videos, I'm going to be exploring almost all of these possibilities with a specific focus on RAG applications, which I know a lot of people have been asking for. And before I go, I wanted to share that all of the code for all of my videos is now going to be on my website, decoder.sh. So each video's webpage is going to be linked in the video description, and all the code will be available, which you can copy and paste. It has syntax highlighting. I think it looks and works really well, so please enjoy that. Finally, I wanted to share that I'm celebrating having just passed 2,000 subscribers. I'm brand new to this, and I really didn't expect anything like this from happening, so thank you all for joining me in this journey. I also really appreciate everyone who has been thumbs upping and commenting on my posts. I want to let you know that I read every single comment, and it's those comments that make each subsequent video a lot better, so thank you again.